Chapter 1: Introduction to Solid Principles. Have you ever pondered on how to make your software design more efficient and maintainable? Well, you're not alone in this. Many software developers have sought ways to improve their code and make it easier to understand, maintain, and extend. One common approach is to adhere to the solid principles. Chapter 2: Single Responsibility Principle. Picture this: you're building a house. Would you want your plumber also handling the electrical work? Probably not. This is the essence of the single responsibility principle. A class, like a tradesperson, should have only one job or responsibility. For instance, a class that handles database operations should steer clear of user interface logic. By ensuring each class has a single responsibility, we can create a design that is easier to understand, change, and debug. Chapter 3: Open-Close Principle. Now imagine that same house you're building. Once you've built the structure, you wouldn't tear it down to add a window, would you? Instead, you'd extend what's already there. This is the basis of the open-closed principle. A class should always be open for extension but closed for modification. In other words, we can add new features or behaviors to a class without altering its existing code. We can achieve this by using inheritance or interfaces to create subclasses or implementers that extend the functionality of a class. Chapter 4: Liskov Substitution Principle. Next, let's consider the Liskov substitution principle. A subclass or implementor should be able to replace its parent class or interface without causing a ruckus in the program. This implies that the subclass or implementer should adhere strictly to the contract or specification of the parent class or interface. For instance, if a parent class has a method that returns a Boolean value, the subclass shouldn't switch the return type to a string value. This principle maintains the consistency of our program and prevents unexpected behavior. Chapter 5: Interface Segregation Principle. Moving on, we have the Interface Segregation Principle. A class shouldn't have to depend on methods or properties that it doesn't use. To avoid this, we should divide large or complex interfaces into smaller, more specific ones. This way, the classes that implement them only need to implement the methods or properties that concern them. For example, a class that needs to read data from a file shouldn't have to depend on an interface that also has methods for writing data to a file. Chapter 6: Dependency Inversion Principle. And lastly, we have the Dependency Inversion Principle. A class should depend on abstractions, not concretions. This means using interfaces or abstract classes to define the dependencies of a class, rather than using concrete classes directly. This reduces the coupling or dependency between classes, making them more flexible and testable. For instance, a class that needs to send an email should depend on an interface that defines the methods for sending an email, rather than relying on a specific email service class. Chapter 7: Conclusion. So there you have it, the solid principles in a nutshell. By adhering to these principles, we can create software that is easier to understand, maintain, and extend. It's not always easy, but it's always worth it. So, the next time you're working on a software project, remember to keep it solid.